There is no doubt that in the present age, data are growing at a very fast rate. Their analysis is becoming a challenge today for the data scientists. It is becoming more difficult day by day to get total insights of these huge data. It is true that a set of finite number of data contains only a limited amount of information on any matter under examination. It is the task of statistics to extract the whole of the available information from the data set on any particular issue. There is a need of some fast method that can extract the whole information from the data set and analyze the information to get some meaningful and useful results. Over the last few years, much progress has been made in processing power and speed, which enabled us to go beyond manual practices. Manual practices are generally tedious and much time consuming. The new developments have made data analysis quick and easy. Machine learning, artificial intelligence, data mining, data science, big data analytics are some important and effective practices widely used in present time. It may be clear without mentioning that in the heart of all these, there is statistics. Machine learning is a technique which develops complex algorithms for processing large data to deliver results to us. Machine learning and statistics are closely related fields in terms of methods and in terms of principles. Then, in what way they are different? They are different in their principal goals only. Let me ask one question. Can anyone learn engineering without knowing the principles of physics? Engineering is based on the principles of physics. Can anyone pursue medical science without having the knowledge of biology? Medical science is based on the knowledge of biology. Can anyone become a mining engineer without having the knowledge of geology? Mining is based on the knowledge of geology. Similarly, one can't know machine learning without the knowledge of statistics. We can say that what physics is to engineering, what biology is to medical science, what geology is to mining, statistics is to machine learning. Statistics draws inferences about populations through samples, while machine learning finds generalized predictive patterns. Machine learning is based upon a statistical framework, as in machine learning, one deals with data which are described using a statistical framework. In other words, statistics provides theory which machine learning translates into practice in order to get efficient and reliable results. The term machine learning was first given in 1959 by Arthur Samuel, who was an American working in IBM and a pioneer in computer gaming. Due to its practical importance, many statisticians and computer experts soon got attracted to it. The various developments made in machine learning during 1960s have been given by Nielsen in his book entitled On Learning Machines, which deals mostly with machine learning for pattern classification. Machine learning models are designed to make the most accurate predictions possible, whereas the statistical models are designed for inference about the relationships among variables. There may be a lot of statistical models that can make predictions, but prediction accuracy is not their strength. Machine learning is all about results. It is likely working in a company where your worth is characterized solely by your performance, whereas a statistical modeling is more about finding relationships among variables and the significance of these relationships. Let us take one example. An example of linear regression. We know that linear regression is a statistical method. In this method, we minimize the squared error between data points. This is done on the basis of a given set of our data, and we do not know how well the model will perform until we test this on other sets of data that were not present at that time. The purpose of machine learning in this case is to obtain the best performance on the test set. For a statistical model, we find a line that minimizes the mean squared errors across all the data, assuming the data to be linear with some random disturbances, which is typically Gaussian in nature. For many cases, our model is to characterize the relationship between the data and our outcome variable. Our interest is not to make predictions about future data. We call this procedure a statistical inference. It is for the method of finding a regression line or a regression curve. But sometimes our primary purpose may be to make predictions using statistical models. But the way the model is evaluated will not involve a test set and will instead involve evaluating the significance and robustness of the model parameters. Here comes the role of machine learning. The purpose of machine learning is obtaining a model that can make repeatable predictions. We typically do not care if the model is interpretable or not. There are two types of machine learning. One is supervised learning, and the other one is unsupervised learning. These types are in different situations and with different data sets. Supervised learning is the type in which, with the help of data, models are trained. In it, models themselves need not find a dependent variable as a function of an independent variable. It needs supervision to train the model to select as what are dependent variables and what is independent variable. As students are taught by their teachers in supervised learning models are taught by the users. Supervised learning can be used for two types of problems: classification and regression. For example, suppose we have images of different kinds of flowers. The task of supervised learning model is to identify the flowers and classify them accordingly. For this, the input data as well as output for that are provided to train the model by the shape, size, colors, and fragrance of each flower. In other words, some examples of flowers in different classes are given to the model. After this, the model would identify the flower and predict the output using a suitable algorithm. Unsupervised machine learning method infers from the unlabeled input data. It does not need any supervision. It finds pattern from the data by its own. No need of any instruction. It is used for two types of problems: clustering and association. Taking the previously taken example of identification of flowers, in unsupervised learning method, only data set to the model is provided, and the model itself is allowed to find the patterns from the data. With the help of a suitable algorithm, the model trains itself and divides the flowers into different groups according to the most similar features among them. It was just a brief acquaintance of machine learning for you. Thank you.